Final project.
Hello, I am Vishwasudesh Pandey. I'm going to present a demo of the EE278 final project. So this project consists of two parts. One is the software implementation and the other is the hardware implementation. In the software implementation, we will use C code to implement the FIR filter onto the NIOS system. In the hardware, we will use Verilog HDL to implement the filter onto the NIOS system. Finally, we will compare both these systems in terms of its performance and conclude which is faster, either the hardware or the software. Now we will add the project. I've already created the software model, so you can see the filter part over here. This is the Qsys project. So uh, you can see that the QIP has been added onto this quarters project. So we'll open the Qsys system builder. Once this system builder opens, we can add all the components that we require to create this software project. As you can see, the system is loading. Once the system gets loaded, we can add the existing Qsys that I've created, or you can create a new one. I will just add this FIR filter software top Qsys, and you can see that it is adding all the components. So it is adding, if you see all these components have been added, you can just filter out in order to add the new one. You can see this NIOS II processor over here, and once that is done, you can add this Qsys NIOS II to this Qsys. So it is an economic version, so that it works on the D1. You can see that the on-chip memory have been added. You can add this only when the on-chip memory component is in the system. So you add an on-chip memory with 20480 bytes. I have used because it may get error if you fall short of memory. Then you add a JTAG UART for the communication. Then the performance counter. This unit helps us to monitor the number of cycles that is required for the C code. So after all the components have been added, you have to connect all the ports. So you connect the data and instruction master to the S1 of the on-chip memory where the instruction is stored, and then you add the data master to the JTAG slave and the control slave of performance counter. You add the interrupt request. Once you have connected all the ports, clock and reset, you have to assign base addresses. Once that is clicked, you will see that the base address has been generated and the end address as well for each of these components. So after that, you have to save the system. Once the system is saved, you are good to generate it. Click on generate. You will see that the Qsys is running. So make sure that everything is okay and there is no error that is left out. So yeah, you can see here that the generated complete with 0 errors and some warnings. You can ignore those warnings. Now we have to add that Qsys to your quarters project. So browse through the name which you had given in the Qsys as well as the quarters, and go to synthesis, and then select IP variation files and select the top QIP. I've already added, so I'm not going to select it again. After that, you have to edit your pin assignments. So if you know the pins which you particularly know for the board that you are using, you have to add it. So I have imported the complete CSV from the Altera website and just renamed the clock_50 to clock_clock. This clock_clock is generated by the Qsys. Once that is done, you have to start compilation. It will perform the synthesis. The next task is to program it onto your board. Now you make sure that USB mask blaster is selected. Now after that, you select this SOF file generated. Make sure that the board is correct, and you can see that the progress is successful. Now we will start the Eclipse tool, where you will have to add the C code and interact it with the system that you have generated. Now select the same project path and create a new folder called software. You can now add a new project by selecting NIOS II application and BSP from template. You can see that you have the option to select the SOPC information so that you can load what hardware you are using. So if you open that, you will see the NIOS II processor has been selected, and then rename the project you want, or give a new name. So and select hello world small so that it uses a reduced library, and click on finish. So since I've already created, you can see that FIR Filter SW1 and BSP file, the supporting files are created. In the hello world C, you will usually see the basic C code, but I've copied my own filter file. So you will see the filter coefficients and input is multiplied, goes through the saturation and rounding logic and accumulates. Then you will use the performance counter to know the number of cycles it takes. These are the inputs. The first test case of mini project 2. Then you build the project. Once you build the project, now you have to run it on the board. So after that, you just click on NIOS II hardware, run as, and then NIOS II hardware. You can see that the filter output is -34 and the total cycles is 1,82,000 and odd. So this is the software implementation of the FIR filter. Just click on start, and you can see that the burning progress is 100% successful.